Hi guys, this is part 2 of my relationship with mathematics. So in part 1 I ended talking about things that things that one might be able to prove as a high school student. I want to talk about what I was proving to myself. Again, the overarching topic of this video and the last one is understanding is more important than memorizing in mathematics. So, for example, when I was about, 11, I was learning about the properties of exponents, and I proved to myself all of those properties that I was learning. I convinced myself that they were true. The book I was using did a good job of explaining it, but I took the trouble, to read the explanations and convince myself that the properties were true. But exponents, maybe one property is 2 squared times 2 cubed equals 2 to the 5th. Properties like that. Alright, that type of exponent, that's like a positive integer exponent. You can have exponents that are negative integers, like 2 to the negative 3. And when you're in high school, that's defined, but you should, understand basically everything about negative exponents. You can have rational exponents like 2 to the 2/3. You can understand everything about that if you try really hard. That basically means 2 squared, and then that's raised to the 1/3 power. This is basically the cubic root of 2 squared. So try to understand everything about rational exponents when you're in high school learning about them, or junior high school or college when you learn about them. Try to understand the properties. The problem, when pure understanding breaks down and you have to rely on intuition at that level of math, is when you get into irrational exponents like pi. Pi is an irrational number, meaning basically it's not a fraction. It can't be expressed as a fraction. 22/7 is a good approximation of pi, but it's not exact. So 3 to the pi is defined in mathematics, but how? 3 to the 3/5, that's 3 to the 3rd power, and then you raise that to the 1/5. But how would you define 3 to the pi? We know it's defined because you can graph 3 to the x for any x. So x's must include irrational numbers. So I guess you just had to accept that for now and maybe wait until you get more mathematical maturity to prove the properties of exponents extend to irrational exponents. The other thing that they tell you in maybe high school is that pi is irrational, and they don't prove it. I'm not sure I approve of that. I don't think there's any real reason for you to know at that level that pi is irrational. I don't think it serves any purpose. So if it doesn't serve any purpose to know, I'm not sure I approve of teachers telling you something without proof. It's for me, it's like spoiling the end of a mystery novel. The way my philosophy of learning and teaching math is, if a mathematical fact is not useful and it cannot be proved at the level at hand, then just don't teach the facts. So I don't think in high school they should be teaching you that pi is irrational, because it's basically a useless fact. And its main use for you would be to see the proof, but if they're not going to prove it, just don't bother with it. Alright, I and complex numbers. So I is the square root of -1. Your teachers probably just said something like treat I as a real variable, pretend it's x. So all the properties that you learn for real variables apply to I. That's how you learn complex numbers. Those are basically imaginary numbers. I guess that's fine. You're not really understanding it because they haven't proved all of those properties. But I is useful if you go to stuff like electrical engineering. It's not really useful for high school students though, so I'm not sure they should be teaching I in high school, because they don't really prove the properties of I. What do you think? I'd love to hear in the comments. I really like math when I can understand it. As I said in part 1, I was a math major, but I I did not really understand I until a few months ago when I took the trouble to prove the properties of I to myself. So, and again, the problem with it, like if your teachers just say, when you're dealing with I, just pretend it's real. The problem, it's not real. It's not a real number. So how do the properties of real numbers just magically transfer over to when you're dealing with I? Another thing that I proved to myself is the distributive law. I was learning that like when I was 11. So, try to prove the basic, a lot of the things in math, in elementary school, junior high, high school, and college, you can prove to yourself, like the distributive law, the associative law, the commutative law. When I say prove, I use three sort of terminologies interchangeably. Proving to yourself, convincing yourself that something's true, understanding. To me, that's all like the same thing. Another thing I'm not sure they should be teaching you is that the square root of 2 is irrational, because that's sort of a useless fact. You could, you can prove it, I think, with some effort, or the teacher should do a proof. I think that would be really cool, and they should do it in whenever you learn that, like in high school, the square root of 2 is irrational, they should prove it. If they're going to teach that the square root of 2 is irrational, if you ask me, it should be proved. And I think it's fun I think they actually should teach that, but they should prove it too. I mean, what's the point of just telling you that the square root of 2 is irrational? So I'm trying to sort of revolutionize the world's education worldwide in math and physics. Math and physics are basically the same thing, if you ask me. I think there's sort of too much stress worldwide placed on memory work, and those subjects are not enough on understanding. As I said in my previous video, I started to grow and enjoy those subjects more when I started emphasizing more understanding and emphasizing memory less. Plus, if you understand something, you sort of just memorize it automatically. I said I used to have, I used to enter math competitions, I would have flashcards with facts in math. I think that was basically pointless, at least for me. I don't recommend learning math and physics with flashcards, but by understanding. The following idea I thought of on my own, and I also heard one of my students say it. I think it's pretty cool. He said, physics is applied math, chemistry is applied physics, biology is applied chemistry, and art is applied biology. And that's true if you think about it. Like, I heard this story that it's sort of cool because we're in the COVID epidemic today where people have to stay home. I heard this story like Isaac Newton was in Cambridge studying. He was at Cambridge. He was in college in the 1600s in England. And there was an epidemic. There was a breakout of the Black Plague. So everybody was sent home. It was shut down. So he was at home and he was in his backyard and this apple fell. He saw this apple fall. And so he's like, okay, so the apple falls, the apple's in the sky, the apple falls. The moon is also in the sky, so why doesn't the moon fall? And to answer that question, the math in the world at that time was not advanced enough to answer that question. So, first of all, he had to learn some math to try to answer that question. So he went to the library, checked out a book on algebra, and learned algebra in a week by reading a book. Isn't that amazing? Then he goes to the library, checks out a book on geometry, learns geometry in a week. Well, the algebra and geometry are not enough basically to explain why the moon doesn't fall. So he has to invent more math to explain why the moon doesn't fall. He has to invent math and physics. So he invents calculus to support his physics that he's going to use to explain why the moon doesn't fall. Isn't that cool? So that's basically why I say math and physics are the same thing, and why physics is applied math. Because math is very abstract, and when you apply it to the real world, you get physics. Well, physics is explains atoms and molecules. So physics basically explains chemistry. In biology, you get to these big molecules. So chemistry explains biology, and then we're biology. We're humans, we're biology, and we create art. So art is applied biology. So that's pretty cool, right? Physics is applied math, chemistry is applied physics, biology is applied chemistry, and art is applied biology. Because of that, I think a principal at one school decided to sort of teach things in that order. He would like say, in my high school, kids should first learn physics, and then chemistry, and then biology. Typically, it's done in reverse. Typically, kids learn biology first, and then chemistry, and then physics. And I think the way they do that, I think it's sort of easier. Even though the application goes in either order, I think for most people, biology is easier than chemistry, and chemistry is easier than physics. Well, it didn't work out very well at that school where they tried to do it in that so-called logical order. When they tried to learn physics and then chemistry and then biology, it didn't work out too well. So anyway, I think in learning you should try to understand as much as you can, but you know, in these applied subjects like physics, chemistry, and biology, so you can understand your way through most of math and physics, but in chemistry, I guess you sort of have to memorize because there's just so much, and maybe you just don't know enough of the physics to understand the chemistry. And then same thing in biology, you might just have to memorize a lot in biology because you don't know enough chemistry to understand, and physics and math to really understand the biology.